This is an instructional video about comparing fractions, and our essential question is what is a benchmark, which is classified as a defining level question. So the first thing we want to ask is what is a benchmark? Because if we don't understand the vocabulary, when we use it, it's going to be a little bit confusing. So a benchmark is something that's a known measurement or value that helps us make an educated guess. And as we start working with estimating our answers and comparing items, it's good to have something that you can compare it to, which is why we tend to use something that we know. Now the next piece is thinking about symbols that we use to compare. So let me get my camera focused. There we go. So the three symbols that we use are these ones right here. Now, what happens is that a lot of students know the idea about something being greater or less, but they don't know which symbol to use correctly, which is why you see that I have them written out here too. In math, we read left to right, just like we do in the English language. And so this symbol here is greater than. This symbol here stands for less than, and this symbol here is equal to or equals. So that classifies as a balancing, saying that something is balanced. So when it comes to actually reading a math statement, I have these here so that we know how to read it accurately. Now when it comes to naming a few important benchmarks, I have some labeled here. So if I have my number line from 0 to 1, the first one that most students can label quite easily is 1/2. Now, everything else are ones that we want to be able to know, and that will really help us when we start comparing fractions to decimals or when we start adding percentages in there too. So knowing where your fourths are, which I have them labeled here, 1/4 and 3/4, and then also knowing your thirds, 1/3 and 2/3. Now, knowing where those are will help us in the future, but really the biggest one that we need to make sure that we always know is 1/2. And then we want to try and push our understanding in knowing our thirds and our fourths too. Now, how do I use this when I'm comparing fractions? Well, I have this here. So I had 2/7 and I wanted to compare it to 4/5. Now, before I put this in here, what I did is I looked at my number, I drew my number line from 0 to 1 and I put 1/2 in there. And I thought to myself, 2/7. 2/7. Does 2/7, is that less than 1/2 or greater than 1/2? Well, 2/7 is going to be less than 1/2. So that's why I put it somewhere over here. It doesn't really matter where it goes, but it's somewhere over there. And then we have 4/5. 4/5, is that greater than 1/2 or less than 1/2? Well, I know it's almost the whole thing, so I'm going to put the symbol over here. I'm going to put it over here somewhere. And it doesn't really matter where it goes. I'm just putting in a spot where in relationship to 1/2, is it greater than or less than? When I'm looking at where I got them graphed on my number line, and I'm seeing that I have 2/7 farther on the left and 4/5 farther on the right. So that tells me whatever's farther on the right is the greater number, so I put that symbol in there. And I read this as 2/7 is less than 4/5. Now, what about the case where we have improper fractions or mixed numbers, like this one? I have 15/4 and I'm comparing it to 1 1/3. Well, we're going to use a skill set that we learned back in elementary school about how to take, this is what we call an improper fraction because my number in the numerator is greater than my number in the denominator. And this is what we call a mixed number because I have a whole number with a fractional part. So I'm going to convert this improper fraction into a mixed number. That's one strategy that I prefer to do because then I have whole numbers to compare and I can use that a little bit easier than if I had two fractions and I created a common denominator. Now, something that I see to be a struggle with some students is how do we convert? Some students like to use mental math. Okay, 4 goes into 15 how many times, and then how many are left over? Here's another strategy that you can use. I'm going to draw 15 dots. And I'm going to put them into groups of 4. So there's one group of 4, here's another group of 4, here's another group of 4. Now those are left over. So how many groups of 4 do we have? We have 3, and then I have 1, 2, 3 fourths left over. And now this is my problem that I'm comparing. 3 3/4 compared to 1 1/3. Okay, well, 3 is greater than 1. So already that symbol is what goes in there. And 15/4 is greater than 1 1/3. And that's what I can do when I have improper fractions and mixed numbers.